class. I'm sorry I cannot be there today. My daughter is homesick, so I am staying home with her today. But we should have out, your day 3 notes and just follow along with the video. If I go too fast, just feel free to pause it and write down what you need to. The beginning parts are just warm-ups, so I'm not going to spend a ton of time on that. I'll look at number 3 and then we'll move on to the new stuff. If you've got the sides of a parallelogram are in the ratio of 2 to 3, if the perimeter of the parallelogram is 80 centimeters, what are the dimensions of the parallelogram? So what happens is if you draw a parallelogram, this will require you to remember a little bit from last unit, the ratio of the sides is 2 to 3. So one side is a multiple of 2 and one side is a multiple of 3. So you put 2x and 3x. Well, we remember that opposite sides are equal in a parallelogram. So if this side's 2x, this side's 2x. And if that's 3x, this is 3x. So then we can utilize the perimeter, being 80, to set up our equation. 2x plus 2x plus 3x plus 3x. So all the sides add up to equal 80. And when you add those up, you get 6, 7, 8, 9, 10x equals 80. So x is going to be 8. And then just make sure that you actually answer the question. It says, what are the dimensions? So they need to know what the two sides are. So this side is 2 times 8, and this side is 3 times 8. So the dimensions would be 16 by 24. 16 by 24 would be your answers. All right, 16 centimeters, I guess I should include units by 24 centimeters. Okay, so let's move on to the new stuff. For number 4, actually this kind of is old stuff as well, but we've got triangle ABC is dilated to triangle DEF. So you can see that we're starting with ABC, we're ending up with DEF. It's obviously getting smaller, so that's called a reduction. As far as the scale factor goes, remember we use S. You start with the original side, so like 12. You multiply it by S, that'll represent the scale factor, and it becomes a 4. So we want to know what we're multiplying 12 by to get 4. When you divide by 12 to get S by itself, you get 4/12, which is 1/3. So the scale factor is 1/3, meaning that the triangle is becoming 1/3 the size of the original. All right, number 5, we did this 2 days ago as well, dilate by a scale factor of 2. So if you look at P is located at -4, 4. You're going to multiply both of these numbers by 2. So P prime is going to end up at -8, 8. K is located at -4, -1, and so then you're going to multiply those both by positive 2, and you get -8 and -2, and we'll plot those in a little bit. I is located at 5, 3, so then you're going to multiply that by 2, you get 10, 6, and then N is the last one. It's located at 1, -1. Multiply those both by 2. You're going to get 2, -2 for N prime. So when we plot these, just don't forget to label them, and then you should be good to go. So we got P prime here. -8, -2 is K prime. 10, 6 is I prime. And then 2, -2 is N prime. Connect the points together, and you should end up with a shape that is double the size of the original. Because the scale factor is 2, it's doubling. Okay, so then let's look at this. This is going to be kind of new. We've got triangle ABC is mapped onto triangle A prime, B prime, C prime by dilation. Use the given information to sketch the dilation, identify it as a reduction or enlargement, and find the scale factor, then find the missing side lengths. So we're going to draw out, triangle ABC. ABC is here. AB is 8, BC is 10, and AC is 14. Then we've got triangle A prime, B prime, C prime. All right, you can draw it a different size if you want. I'm just going to keep it the same size. A prime, B prime is 12. We eventually need to find this side and this side. So we need to figure out whether it is a reduction or an enlargement. All right, so we're going from this triangle, ABC, to triangle A prime, B prime, C prime. If you notice, like AB starts as an 8, and A prime, B prime it grows to be 12. Since it's going up, we know that it's going to be an enlargement. It's getting bigger. When you compare those two sides, it's obviously getting bigger. So that's an enlargement. We need to find the scale factor. So what you're going to do is you're going to start with the original. We have to use two sides that actually match up. So I'm going to use the 8 and the 12 because those are the only sides that we have actual numbers for. So we've got the original triangle side 8 times the scale factor, and then it becomes a 12. We need to find out what the scale factor is, so we divide by 8. And you get, when you divide by 4, you get 3/2. So the scale factor is 3/2. What happens then is basically this triangle, every single side is becoming 3/2 bigger, or 1.5 times bigger. So if you do 8 times 3/2, you'll get 12. In order to get x, what you need to do is you need to do 10 times 3/2, because 10 matches up with x. If you do 10 times 3/2, you're going to get 15. So this missing side b prime c prime is 15. And then you're going to do the same thing for the other side. AC is 14. You're going to do 14 times 3/2 to make it 1.5 times bigger. And you're going to get 21 for that missing side. So you got to find the scale factor, and then you can multiply the other sides to find out what the new sides are. All right, let's move on to the next one. This is very similar to number 5. So we're going to start off by drawing a picture. We've got triangle ABC. AB is 16, BC is 20. And then we've got the other triangle, A prime, B prime, C prime. And A prime, B prime is 4, A prime, C prime is 7. The goal is to find AC and B prime, C prime. So I'm just labeling those with X and Y. So we got to find out what the scale factor is. What we're going to do is use two sides that match up that we have actual numbers for. So the 16 and the 4 match up. To find the scale factor, you start with the original, you multiply by S, and then we equal it to the new side. When you divide by 16 to get S by itself, you're going to get 1/4. So this triangle is becoming a fourth of its original size. So to find out like what Y is, we're going to have to do 20 times 1/4. Okay, 20 times 1/4. And when you do 20 times 1/4, you're going to get 5. Now, to do the X, we know that if we take X and we multiply it by the scale factor, we're going to end up with 7 as our new side. So it's X times 1/4 equals 7. Well, we got to get rid of the 1/4. So this is the same thing as 1/4 x equals 7. To get rid of the fraction, you can divide or you can multiply by the reciprocal. So that's what I'm going to do. X ends up equaling 28. All right, so if you were to do 1/4 of 28, you'll get 7. 1/4 of 20, you get 5. 1/4 of 16, you get 4. So it should match up. This side, just to double check, it should be bigger than this side because you can tell it's getting smaller. Oh, that reminds me, we were supposed to say reduction or enlargement. Since obviously the sides are getting smaller, this is a reduction. So we have a reduction, and we know what all the missing pieces are now. Let's look at a graph. So on here, use the graph of triangle JKL and triangle PQR, and we're going to write a composition. So the letters are, for some reason, missing on here. We've got JKL. We're going to put PQR here. And we're going to use the graph, the composition of transformation that maps triangle JKL to triangle PQR. All right. So what we want to do is we want to look at the coordinates of each of these. So like J is located at -6, 1. K is located at -5, 4. And then L is located at -3, 3. And then we've got PQR. So like P is located at 2, -4. Q is located at 4, 2. And then R is located at 8, 0. So we have all the points here, and what happens is we eventually need to get JKL to match up with triangle PQR. You can tell just by looking at it that triangle JKL is way too small. It needs to get bigger. So what we can try and do is, it's going to take a little bit of guess and checking, but we got to figure out how much bigger we need to make triangle JKL. Like what we want to make our scale factor. Do we want to make it 2 times bigger, 3 times bigger? It's usually not going to be a decimal just because it's like a guess and check type thing. So let's try and make it bigger by a scale factor of 2. All right, if we were to make this bigger by a scale factor of 2, doubling the size, J would end up being negative 12, 2. K would end up being negative 10, 8. And then this guy would be negative 6, 6. All right, we're just multiplying everything by 2, doubling it. So negative 12, 2 is going to kind of go off the grid a little bit, but negative 10, 8 would be up here, and then negative 6, 6 would land me like right here. So I'd end up with this triangle here, and that looks like it's about the same size as this triangle. Now the only thing that needs to happen is this triangle needs to move. If you remember, moving something along the grid is called a transformation. Translation, I mean. So it needs to translate. We're obviously going to need to move this thing down and to the right. So let's see. If we take this from here, if we match up K, actually, I lied. This is K and this is L. If we take L and we try and match it up with R, all right, because it's the last letter, we want those to match up, we're going to have to go down 6, and then we're going to have to go to the right 14. All right, 6 and then another 8. So we're going to need to translate this thing down 6 and right 14. And if we do that for every single point, so if we take L and move it down 6 and right 14, we're going to land right here. If we do that to K, we go down 6 and right 14, we're going to land right here on Q. And then J is a little bit harder because it's off the grid, but if we go down 6 and right 14, you're going to end up right here on P. All right, so they're asking you, what is the composition of transformations? So like what moves do we need to get it from where it starts to match up here? We need to multiply triangle JKL by a scale factor of 2. And then it needs to translate down 6 and right 14. All right, so it's going to end up being usually some kind of a scale factor of some sort, and then translate. Actually, instead of multiply, we're going to use some vocab. We're going to say dilate. All right, so it's usually going to include dilating and then translating. So we're going to dilate the triangle by a scale factor of 2, and then translate it down 6 and right 14. Are the triangles similar? We're going to learn more about similar triangles later, but the answer to this, anytime that you are dilating and translating, is you're going to say yes, dilations create similar figures. And we will get more into that soon in the next couple of days. But anytime that you're taking a triangle and you're doubling it in size or tripling it in size or cutting it in half, those two triangles are going to end up being similar. They're exactly the same size or the exact same shape but different size. All right. And then like 8 and 9, these are kind of review. I would try these out and see how you do. The answers are going to be on Canvas for you, so you can check those out and make sure that you did those correctly. And then you're going to want to work on the homework, which is only a few problems. I believe it's 26, 27, and 28. It's written up on the board for you. So try these two out. Check your answers with the notes already posted on Canvas, and then start working on those 3 problems for homework. And then we'll continue to go through this and some new stuff tomorrow. All right, thank you for listening. Have a good night. Bye-bye.